do example of using sum and difference identities to find a value of trig functions. So suppose we want to evaluate sine of 195 degrees. So we already know that 45 degrees, we know how to evaluate sine and cosine of 45 degrees, 90 degrees, 135 degrees, and then I'm just basically taking multiplies of 45 degrees and then 180 degrees and so on. And then let's see, maybe stick 30 degrees up there. So $30 degrees, 60 degrees, we know 90 degrees, and then 120 degrees, and etc. So what I'm going to try to do, you could do the same things with 60 degrees, 120 degrees, and then 180 degrees. I'm just multiply 60 degrees and etc. Well, there is definitely more than one way to do this, but certainly it looks we could use 60 degrees and then 135 degrees. So equal sine 195 degree equals sine 60 degrees plus 135 degrees. So sine of 95 degrees is the same thing. Well, that's going to be 60 degrees plus 135 degrees. And now we just have to use our identity and recall our sum identity for sine of the first one. We take cosine of 135 degrees and then 60 degrees. First, sine of 60 degrees, cosine of 135 degrees, plus cosine of 60 and sine of 135 degree. That's the same thing. That's the same as sine of py over 3. That's going to give us roots 3 over 2. Cosine of 135 degrees, that's going to be in the second quadrant, and that's going to give us negative roots 2 over 2, and then cosine 60 degrees, that's going to give us plus 1/2, and then sine 135 degrees. So we have positive roots 2 over 2, and now we can just simplify this down. If we multiply, we'll get negative square root of 6, negative square of 3 times square root of 2. We can write that as the square root, negative square root of 6. And then 1 times 2, roots of 2 is simplify roots of 2. So we would have our common denominator of 2 times 2, which is 4. So that this is the solution for sine of 195 degree.
Hi there, so today I'll be explaining different identities of cosine. So the formula for cosine is cosine x minus y equals to cosine x times cosine y plus sine x and sine y. So to further know how to solve this, I'll give an example. Let's try, how about cosine 2 pi over 3 minus pi over 6. So using the formula from above, we're gonna write it down below to continue on solving. Cosine x minus y is equals to cosine x times cosine y plus sine x sine y. So using the value I've given, 2 pi over 3 is the x value and pi over 6 is the y value. So we all write it down and we'll have equals the cosine 2 pi over 3 since it's our x value. Multiplied by cosine pi over 6 since it's our y value plus sine 2 pi over 3 again because it is our x value. Multiplied by sine y. Sorry, but I have mistaken in writing cosine. Replace it with sine pi over 6. So cosine 2 pi over 3 is equals to 120, which is cosine. It's supposed to be negative 120. So we'll have negative 1 over 2. multiplied by cosine pi over 6, which is 30, and 30 is the square root of 3 over 2. Plus sine 2 pi over 3. Let's erase that. Sorry. So that will be, since it's sine, it is on positive 1 over 2. Multiplied by square root of 3 over 2. So negative 1 half times square root of 3 over 2 is equals to negative square root of 3 over 4 plus square root of 3 over 4. That is equals to 0. So don't worry if it's 0 because 2 pi over 3 minus pi over 6 is cosine 120 minus 30. So that will be cosine 90 degrees. And on the x-axis, it is equals to 0. So the answer is 0.
Module 15, Deriving Trigonometric Identities Involving Sum and Difference of Angles. Find the value of sine 75 using sine A cosine B plus cosine A sine B. Sine 30 plus 45 is equals to sine A cosine B plus cosine A sine B. Let's substitute it. Sine 30 cosine 45 plus cosine 30 sine 45. Substitute it again to the value. Sine is equals to 1 half. Cosine 45 is equals to square root 2 over 2. Cosine 30 is equals to square root of 3 over 2. And the last one, sine 45 is equals to square root of 2 over 2. Multiply 1 times root of 2 is equals to root 2 times 2 times 2 is equals to 4 plus radical 3 times radical 2 is equals to radical 6. 2 times 2 is equals to 4. Combine, that will be 2 plus 6 over 4.
The formula that I'm going to use is cos x plus y equals cos x cos y minus sin x sin y. Now, I have an example here. It's cos 105 degrees. We will think of a common angles that when we add, the answer is 105 degrees. So let's say 45 degrees plus 60 degrees, it's equal to 105 degrees. Now we have our x and y. Our x is 45 degrees and our y is 60 degrees. The next step is to substitute the value of x and y. It will be cos 45 degrees plus 60 degrees. Cos 45 degrees cos 60 degrees plus sine 45 degrees and sine 60 degrees. Now, we're going to substitute the value of cos 45 degrees, cos 60 degrees, sine 45 degrees, and sine 60 degrees. So, the equivalent of cos 45 degrees is square root of 2 over 2. And the equivalent of 60 degrees is 1/2. Plus, the equivalent of 45 degrees is equal to square root of 2 over 2. And the sine 60 degrees is equivalent to square root of 3 over 2. Then, the next step is to multiply the sine and the cos. These two, it will be square root of 2 over 2 times 1/2 is equals to square root of 2 over 4 plus square root of 2 times square root of 3 over 2 is equals to square root of 6 over 4. And because they have the same denominator, we're going to add both of them, and it will be square root of 2 plus square root of 6 over 4. And that's it.